So I'm Vikas. I am VP of Advanced Technology and Product Strategy over here. What I'll be doing is I have a set of lead architects coming in here to help me out with providing you with under the hood journey to what we have built over here. So we have divided this entire presentation into 4 broader categories. And please feel free to ask any questions anywhere you want. Depending on the time we have, we may be picking up the pace or slowing down. But our goal is to walk you through these 4 major categories. We'll start with the flash array hardware. So this is where Violin pioneered the flash industry. And it's been 8 years, mature platform, and we'll walk you through what has changed and why this, the architecture flexibility has allowed us to continue evolving and maintain that performance density and the resiliency leadership that we had helped start several years ago. We'll give you a deep dive into Concerto software. So this is where the data management software and the services come into the picture. This is what Steve was referring to is very essential for the transition of flash from the tier 0 into the primary. This is the tier 1 storage that we're talking about, where we're competing with the primary data storage, competing against VMAX, VSPs of the world, and so forth. Then we're going to give you under the hood, walk into the ARIA software. This is the software responsible for management of the health of the 3U box that we have, taking a look at the various components, managing for the customers, the health of the VIM, the VCM, or all those terminology that I'll be introducing just in a bit, but very important component to our architecture. We'll talk about that. And we'll round it up with the Symphony software, which is our single pane of glass management software for multiple Violin arrays deployed in your data center. And we'll have a quick demo in that as well. So very quickly, so the people who would be assisting me in the Flash Array Tech deep dives are Jim Bowen and Chris Chang. And I'll call, they would be joining me here as we go through their section. So first, let's go through the key components that I'll walk you through. We'll provide you with the array hardware overview. I have a sample here, which once the session closes, I'll be happy to walk you through. But pictorially, I'll try to help build a context as to what the various components of this array hardware are. And I'd like to answer some of the questions that you had raised. Then we are going to take you a little bit deeper dive into the system and the flash fabric architecture. Deep dive into it as to why density is not the only thing that you can do. The density has to be complemented with right level of resiliency and right level of performance. Otherwise, that density is pretty much useless from the primary data center use point of view. So we'll walk through that. Then we'll go ahead and talk about the Violin patented Violin V-Ray technology, because early on, Violin had recognized that traditional rates are, will not work for the flash. So they invested significant time and energy to come up with Violin patented V-Rate, and that is why we give the customer the sustained IOPS and sustained low latency that we give, and we'll have detailed deep dive into that one. We'll then provide a deeper insight into the VIM, the SSD versus VIM, all those questions we want to answer. We are not here to say SSDs versus VIM, what we should be using, what we should not be using. We're just here to walk you through and tell you why the VIMs that we have built are more suited for the system that we have built. It's the sum of the parts. It's the system as a whole counts. And VIM, which is the equivalent of SSD, has the interfaces that we have built because we own the software and hardware to provide that integrated experience to the customer. And yes, and tomorrow, if the SSDs catch up to that level, we may be able to use the commodity SSDs, but they aren't there today. And would like to highlight what are those some of the key integration. And then software and hardware integration. We are probably only the very few in the industry which owns the entire hardware and the software. So we have been able to build a deeper integration between these two to provide you, again, high performance, high resiliency, high flash wear life, and low cost. So very first, let's take a look at the building blocks. This is extremely high level. So we buy flash chip through our special partnership with Toshiba. We put together our Violin memory module. This is where we built our own FTL, and some of the lead architects from their team are here. And in the following sections, they will be picking up on what the secret ingredients that we have in over there. Then we arrange them into the logical groups of the V-Rate, and we'll have deeper discussion on the V-Rate. It is very essential for the sustained IOPS and sustained low latency that we're talking about to provide the resiliency and the performance at the same time. And then you have set of V-Rates densely packed into this, and there is another slide coming up on this side, and out comes with the controller in over there, a 3U box, 7300, 3U box with the density capacity that Steve talked about earlier. Self-complete box. It has all the data management software, it has all the performance, it has all the resiliency over here, no dependency on the external component at all. Then you take, but this is not, it doesn't provide you the scale up. It is densely packed. Yes, it can take you to the capacities that we talked about in the previous slide. But if the primary data center needs something which scales over the period of time, that's where we have 7700. So you have external controller and the shelves. So this is the controller and the shelf model. So this is the 7700 product line.
And the shelves are 7300s, right?
Yes, a reduced version of 7300. So they are there. Okay. So now let's take a look component by component. This is the customer view. And this is important because that will help you correlate as we go through the deeper down discussion into the architectural weeds. So this is the 3U box, which is seated over there also. Take a look. This is the flash fabric architecture. So this section is very key to our technology. This is where all the flash management resides. And when we go through the architecture, we'd like to explain how it delivers the high sustained backend performance, high density and high resiliency. And again, packing density is not a problem, right? You can buy off the shelf chassis, plug it in with high density VIMs, and here you go, you have a dense box. But that's not what you want to do. You want to couple it with high performance, resiliency, and that's where this architecture has gone in, and we'll have a deeper look into that one. Then we have array control modules. These are responsible for the system health, providing the PCI switching capabilities and so forth. Then you have active flash gateways, and this is where our data management software runs. So data management software connects to flash memory fabric over PCI switch, and this is it. This is where our all the Concerto software that we have optimized over over 2.5 years resides in. And then to round it off, that's where the I/O modules are. Very compact, very small. In 3U box, you get this. So this is our 7300 box that we have. It's compact, it's matured, and it's modular. So when we released this box several years ago, it looked the same. Today, it looks the same. It's very modular, so it allows us to change. Oh, sorry.
So I read FC and 10 gigabit Ethernet, but not InfiniBand. Is this the
Yeah, so that is also there. It's probably
okay.
That's okay. So if you take a look here, this is the Vim ecosystem. So as we go to 2 terabyte, 4 terabyte, and all those, this is all that needs to change. If you want to adopt to a newer Intel processor, this is a processor chip change over here. If you want to change different I/O modules, this is the change over here. Very modular. So you basically progress yourself forward with the ecosystem. You don't have to revamp the system if a new thing comes in. Allows us to maintain the pace with the ecosystem as they provide the ingredients that we need for this platform. So the platform that exists today is very different than it was 9 years ago. But the beauty is it's built out of the same baked architecture that we released a few years ago.